This is Heinz Wonnung speaking, CEO of Felicitas Customized Engineering. In this little video I will demonstrate Felicitas PCBSim, our circuit simulator, nicely coupled to the famous cuts of the eagle. In order to explain what Felicitas PCBSim is, I will shortly start its help system and navigate to the overview page, which we have here. Here we see a very rough schematic of Felicitas PCBSim. It consists of mainly six modules. The core of it is the SPICE simulator, which is based on the famous Barkley SPICE engine. And then we have three modules: the transmission line modules, the EBIS models modules, the S-parameter editor module, which are all for signal integrity simulations. And we have the library editor, which deals with SPICE simulation models. All of it is accessible through the schematic editor, in this case Cuts of the Eagle. Felicitas PCBSim is able to simulate almost all electronic circuits, being it low frequency, high frequency, low power, high power, amplifiers, filters, switched mode power supplies, whatever. In this little demonstration, I will now simulate a very simple oscillator, which we have here on the left-hand side. This oscillator is from one of the examples which are shipped with Felicitas PCBSim. Now, in order to simulate it, I have two additional GUI elements: simulate current sheet and simulate all sheets. This is installed with Felicitas PCBSim. And for the time being, I will use the simulate current sheet, which I will press now. Now what happens is the whole circuit is transferred to Felicitas PCBSim, and we see here on the right-hand side on the simulator a tree view with all the components, and we see an oscilloscope with the signals we are going to, to display, but currently we haven't any. We have here a list of warnings, which I will look at shortly. And the most important warning is the one with the component G1, and PCBSim says, could not determine type of component G1, ignoring component. Well, this is bad news because G1 is the power supply. And so without the power supply, our little oscillator will not work properly. So what I'm going to do is I will tell PCBSim that this is a voltage source, and this can be done very simply by right-clicking on it and selecting the context menu entry PCBSim. A dialog opens, which is already controlled by PCBSim, and this says this component G1 is excluded from the simulation. Use change type to change its type if you want to have it simulated. I do want, so I press change type. Now a list opens with all the components which are suitable for G1, or which can be assigned to G1. For the time being, I will use a voltage source and press the OK button, and another dialog opens which allows me to edit the properties of the voltage source. I want to have a DC voltage source, and I want to have it simulated with 9 volts, and I press OK. By the way, on the right hand side we see a short oscillogram of this voltage source. Of course it's a DC voltage source, so no surprises here. Okay, so if I transfer the schematic again, we see that G1 has now appeared, and now I can simulate it by just pressing the Start Simulation button, which I've done. The simulation has already been finished, but I don't see anything because I did not select any signals for being displayed. This can be very simply done by expanding any of the nodes which are representing the components, and beneath the components we have all the signals which are connected to this component. For example, the pin collector. If I press now the space button, I see on the right hand side the signal on the collector. Well, it's more or less a rectangle. Not very nicely, but it is okay. I can measure here the time, which is, for example, 2.2 milliseconds. Now, it is of course a bit cumbersome if I, after each simulation, if I select the nets in the tree view for being displayed. So what we have done is we have added a little simulation library, which for example contains a component called probe V for voltage, which I have added here now. And this component allows me to mark any net for being displayed immediately in the simulation. Again, if I do a right mouse click on it, choosing PCBSim, now a different dialog opens which allows me to select the color. In this case I will do it white, and I make it a bit wider so it is nicely recognizable. And I simulate again by simulate current sheet and press the simulate button. And now we see a very nice white signal. So this concludes our little demonstration. I just wanted to show how simple it is to simulate a schematic from Cuts of the Eagle. More or less the two things you have to remember. One button, simulate current sheet, and the other one being the context menu entry PCBSim. Thanks for watching, and bye for now.